Hi everyone, we're Group 6 and today we'll be presenting our proposal for a unified data platform for cold chain logistics. Cold chain operations deal with extremely high stakes data. In this industry, even a small temperature deviation can destroy millions of dollars worth of pharmaceutical products. The problem is that many organizations still manage GPS data, sensor readings, and operational records in separate systems. These data silos make it hard to see problems early. Our goal is simple: to design one unified data platform that supports real-time decisions, accurate reporting, and strict regulatory compliance without adding unnecessary cost or complexity. Moving on, let's look at the problem and the key stakeholder needs. Cold chain logistics generates a huge amount of data from GPS tracker, temperature sensors, and operational system. But because this data is fragmented across different platforms, organizations experience delayed alerts, inconsistent reports, and compliance gaps. These issues directly affect product quality and regulatory risk. From a business point of view, operations team need real-time dashboards, clear alerts, and consistent KPIs. Today, incident detection is often too slow, and different teams see different numbers, which makes quick response difficult. From a technology point of view, IT teams need something that is low cost, scalable, and easy to maintain. Fragmented pipelines and duplicated logic increase both workload and operational costs. From a compliance point of view, regulatory teams need strong access control, audit logging, and data security. Without this, the organization is exposed to regulatory penalties and legal risks. Our platform is designed to meet all three needs at the same time, rather than solving one problem while creating another. Based on these needs, we define success using three simple ideas: fast, accurate, and also safe. Fast means real-time alerts for temperature excursions and route deviations, a streaming processing path, handle sensors and GPS data as it arrives, so issues can be detected and acted on within seconds or minutes. Accurate means official reports and KPIs come from a batch processing path that applies full validation and reconciliation. This ensures everyone across the organization is looking at the same trusted numbers. Safe means governance is built in from the start. The platform enforces role-based access, encryption, PE masking, and audit logging, so every access is tracked and compliant. When this came together, the result is less spoilage, faster response to incidents, better efficiency through automation, and full traceability for compliance. This is the foundation of a reliable and also scalable cold chain data platform.
Today, I will present the architecture blueprint for our unified data platform. Our vision is to create a single trusted source of truth that powers real-time operations and strategic analytics. To achieve this, we've designed a system anchored in four principles. Firstly, clear separation of data across dedicated layers to eliminate redundancy. Second, the fit-for-purpose storage, selecting specialized engines for different workloads to optimize cost and performance. Third, coordinated processing, where streaming and batch pass work in tandem to deliver both speed and accuracy. And first, the principles of a single source of truth, ensuring every downstream report and dashboard stems from one curated, reliable dataset. This foundation ensures our platform is fast, accuracy, and safe. The platform's engine is a three-layer architecture coupled with dual processing paths. Data flows from the raw storage, an immutable record of all source data, into the clean curated layer. Here, it undergoes the critical transformations, including the schema validation, duplication, cleaning of sensor inaccuracies, such as the GPS strips and enrichment with business context. This layer is our official trusted data product designed for quality and consistency. It then fits the serving layer, which exposes data through optimized stores for dashboards, alerts, and APIs. To feed this data, we run two complementary processing modes. The streaming path provides velocity processing events in seconds to minutes for immediate and anomaly detection and operational alerts. It's about fast response. The batch path provides regional processing complete data sets on a schedule to apply comprehensive business logic, historical corrections, and reconciliation. It's about perfect accuracy for official reporting and KPIs. This dual approach ensures we meet both operational tempo and analytic depth. Underneath, we implement fit-for-purpose storage, a BI reporting store for complex analytic queries, and a sensor telemetry store for high-velocity time series data. This technical separation is a key to performance and cost efficiency. However, from the user's perspective, these complexities are invisible. They interact with a unified consumption layer, a single gateway featuring standardized dashboards, governed data sets with consistent metric definitions, and role-based access control. The strategic benefits are clear for business users: consistent, reliable numbers across every report and team, enabling confident decision-making. For technology teams, a dramatic the reduction in the number of custom fragile pipelines to build and maintain. For compliance, transparent data lineage and a clear audit trail from reports back to raw source. By bringing all data into one governed, efficient architecture, we turn information into a unified strategic asset. So that's all for my part.
Then in my part, I'm going to walk you through our data pipeline end to end. And the goal is to take messy cold chain data like sensor reading and logistic updates and turn into two things people actually use: real-time alerts for operation and official reports for compliance and managing reporting. So let's look at our big picture. We basically have two kinds of inputs. First, we have frequency telemetry, like temperature reading, GPS location pings, and sometimes vibration or shock signal. Second, we have operational system data like shipments, detail, and required temperature range, the SLA targets, and the status changes such as handover or warehouse check-in and check-out. So all the data goes through the same structure. We land everything in row, we clean it and make it consistent in clean, curated, and then we serve it in serving store for dashboards, alerts, and BI. We run into two modes: streaming for speed and batches for accuracy. Then I'm going to talk about ingestion and row landing. So in streaming, data comes in all the time. So we do a few lightweight checks for right away. We check that the message has the required fields. The types looks right, the ID are sensible, the value are within basic bounds, the timestamp is not obviously wrong. If something fails the basic schema check, we don't just delete it, we put it into a quarantine queue so someone can review it later. And then the healthy data keeps flowing. Then we write the records into the row layer as append, only, and immutable. We keep the original payload and timestamps because if there is an incident or an audit, we need a full trial. Then is the like clean and the curated. This is where the raw signal become trusted data. We standardize unit and time zone, and we enrich telemetry with shipment content such as temperature limits, plan routine, and SLA thresholds. We deduplicated repeated message processes by event time and accept late events within a watermark window, which batch backfill fixes very late data. We also apply practical rules such as GPS filter jumps and flags, owning sustained deviations and temperature uses bounds, plus a persistent rule to avoid false excursion. And lastly is the output and the reliability. Streaming generates fast alerts and near real-time dashboards for executions, routine deviations, missing pings, and severe anomalies. Batch produces audit-ready KPIs such as OTIF, SLA adherence, execution statistics, incident counts, and LAN vendor comparison. Both rely on the same curated definitions, and the reliability comes from in idempotent rights. The deep duplication, reprocessing, backfill, and monitoring for lag, job healthy, data quality, and alert spikes. So that is the pipeline, fast for operation, accurate for compliance, and consistent across teams. Then moving on to the next teammate.
So this slide explains how we manage data access in a compliant way. First, we divide data into three layers: raw, correlated, and the serving. Raw data is stored as immutable records. This means the original sender data is never changed. All cleaning and processing happen in the correlated layer. Clean data can be used without touching raw data. We control access using role-based access control and the least privileged role. Each role only sees what it needs. As shown in the table, operations teams see dashboards, data science use the credited data, and IT and compliance teams have read-only access. This slide shows how compliance is built into the system. To meet the FDA requirements, original sender data is kept unchanged. Reports and analytics are created in a separate correlated layer. Access to regulated data is strictly controlled and monitored. Every data access is written to an audit log, including who accessed the data and when. This allows full traceability during audits and reduces the compliance risk.
In this section, I will talk about the value, cost, and competitive advantage of the platform. First, in terms of value, the platform helps reduce waste and loss. By monitoring GPS and temperature data in real time, problems can be detected earlier, before they become serious. Second, it allows teams to respond much faster. Instead of discovering issues days later in reports, real-time alerts let teams act within minutes. So we move from reacting late to fixing problem early. Third, automation saves a lot of time and effort. Data collection, checks, and reporting are automated, which reduce manual work and reliance on spreadsheets. Finally, the platform improves trust and uh, compliance. Governments, excise control, and audit logs are built in, so regulators and internal teams can rely on the data. From a cost perspective, the platform is designed to be cost aware. We start with an MVP approach, focusing only on the most important features instead of building everything upfront. For ongoing costs, expensive resources like steaming are used only for critical alerts. Batch processing and tiered storage are used for reporting, which helps keep cost under control. The design creates three key competitive advantages. First, operation of safer are more reliable because governance and security are built in from day one. Second, real-time alert and unified dashboards provide better visibility and faster response across teams. Third, the modular architecture makes the platform easy to scale and maintain over time without redesigning the whole system. Uh, To ensure successful delivery, the platform follows a phased roadmap and manages key risks. We follow a simple three-phase roadmap. Phase one focuses on immediate business value, including critical real-time alerts, co-reporting, and basic governance. Phase two scales the platform by adding more data sources, broader coverage, and stronger data quality rules. Phase three focus on optimization, such as cost optimization, smarter anomaly detection, and higher automation. There are three main risks are and mitigations. First, poor data quality could lead to incorrect alerts or unreliable reports. This is mitigated through validation rules. Uh, the application and continuous data quality monitoring. Second, costs may increase as data volume grows. This is controlled through usage monitoring, budget alerts, uh, and storage, and regular cost reviews. Third, access control mistakes could lead to security issues. This is addressed through uh, role-based access control, list uh, privilege principles, and audit logs.